Hello, and welcome back to Learn It from a Layman. I am Carl Christensen, and today it's just me and Dr. Johnny. Johnny asked specifically for Tim not to come.
That is true. We were like, Tim, what's your schedule? And then we used the times he's not available to.
Those were our starting point. That we sicked a herd of toddlers on Tim. We figured that the AI couldn't do him in, but we're pretty sure the toddlers will get it done. So.
Yes, they will. Boss baby.
Speaking of herds of toddlers, Johnny, as a pediatrician, you will be taking us today through the basics of organs, right?
Yes, I think that's the plan. We'll see how
the plan.
I get sidetracked. I have ADHD. We'll see.
Wait, was it self-diagnosed?
No, just other doctors that are like, have you been diagnosed yet? I mean, they're trying to say it in a way. You get off topic easily.
Okay. All right. Well, we'll stay on topic best we can here. Okay, let's start with a definition of what an organ is, Johnny, because I am confused by what an organ might be.
Yeah. So organs are, I think it's easier to explain if you explain kind of like at the cellular level what's happening. So you have a whole bunch of cells that like function together to make a tissue, and then a tissue is like the cells in an area that produce and the stuff that they make. And then if you bring more than one tissue together, then that's what defines an organ. So usually an organ has like a specific purpose in the body, and it's just a way to, take parts of the body and kind of separate them so it's easier to think about instead of thinking about everything as a whole.
Sure, that makes sense, and it might make more sense as we walk through some of these organs. But let me give you an example of what confuses me. So is the throat, my throat right here, is that an organ?
Well, yeah. So I mean, if you're talking about your neck, there's a whole bunch of organs in your neck, right? So you have, technically, like even every bone is its own organ. Every muscle is its own organ. So a lot of times when we talk about organs, we end up talking about organ systems to make it a little bit easier. Like we talk about the cardiovascular system instead of talking about the heart and the aorta and the pulmonary arteries and the, like all the capillary beds and all those different, the blood, all those different types of things to kind of make it a little bit more simple. But if you have a bunch of tissues that are put together, that makes an organ system, an organ. So technically, bones have different types of cells that have different types of things they're secreting to create this structure. And they have blood vessels that run through them. They have nerves that run through them, which is why it hurts to break a bone. And so each bone makes the definition of an organ. So yeah, as far as like your throat goes, there's tons of different organs in your neck. Your neck is very complicated anatomically, because you have like your larynx, which is like where your voice box is, and part of your esophagus, which the esophagus is an organ. You also have muscles that run through there. You also have vertebrae. You also have the spinal cord, which is an organ. So there's lots of different organs in the neck. And I think a lot of times we think about our big main organs, but there's lots of organs in the body. I think a lot of times when people talk about organs, they're like, oh, it's like the guts,
the stomach, and, right?
Yeah, and the breathing stuff.
Okay, so if I signed up to be an organ donor, are you telling me someone could steal my throat after I'm dead?
I mean, I guess it's possible, but usually that's not like something that's typically donated. So the main organs that get donated um, are things that need to be able to function after they're taken out of one person's body and put into another. So the heart is a very good example. The heart doesn't need any connections to do anything. It has like these channels that allow it to beat on its own without any other nerves or anything like that. Your nerves that go to your heart can help speed up or slow down your heart rate, but they actually don't. It's not what makes your heart beat. It has its own intrinsic system that makes it beat. So the heart is one that can be transplanted. There's also the liver is a common one that gets transplanted. The kidneys are commonly transplanted, which control your electrolytes. They also do so kids that, or I guess anybody that loses a lot of intestines. If you don't have enough intestine, then you're not going to be able to digest your food as well. So those people are called short gut. So their gut is too short to absorb what it needs. So they basically have chronic diarrhea and malabsorption. So they're not absorbing the nutrients that they need. So they can get if they're in such a spot where they have to get IV nutrition, that can be very damaging to the liver and other organs. And also, you have to have a line that goes into a system that's supposed to be sterile. And if it gets infected, it can be, it's big time. Like kids get super sick or adults get super sick. So a lot of times they'll do a bowel transplant, and they've realized that the bowel transplants tend to work better if you transplant it with the liver and the pancreas as well. So they'll do a multi-organ where they do the liver, the pancreas, and the intestines all together. They take out the spleen, so you don't need the spleen. Well, the spleen's important, but you don't absolutely need it. And then transplant like all the rest of the stuff. Leave the kidneys in the donee. I don't know what it's called. The recipient? I don't know.
Right. Yeah.
I
Okay,
like
so
it's kind of fun.
donee. Yes, we'll stick with donee. Okay. That sounds incredibly complicated. We'll come back. Okay, so let's talk about you've already started talking about some of the different ways that you can get organs donated. I'd like to end the podcast talking about the various ways that organs can explode, because I thought that would be a fun way to end.
Explode?
Appendicitis,
All right.
for example.
Sounds good.
Does it have to be explosion specifically, or are we talking just about different failure modes?
Well,
no, it has to be explode.
Both. I don't know. We'll hammer it out when we get there.
On combustion, like where are we drawing the line here?
Yes, exactly. There has to be some variety of fireball associated.
Okay, sounds good. A fireball can ruin any organ.
Okay, but I wanted to kind of start just walk through what most people said. Like most people think organs, you're thinking, I don't know, torso area and head. You already told us that bones are organs, your skin is an organ. So your appendages, like your arms and legs, they have organs. They are organs, right? Or they have organ components, but they're just not, they're called appendages for a reason, right? They don't have any life-sustaining organs. Is that right?
Yeah, that's true. Your limbs are made up of multiple different organs, and a lot of, I guess you could consider it part of the musculoskeletal system. Would be all those would make up that organ system.
Okay. So there's no organ in my leg or like obviously you get a leg chopped off that is going to like change the way the rest of my body functions, right?
Correct. Yeah, that's true. Well, you don't have to have a leg. It's just nice.
It is nice. I'm appreciative. Okay, so I kind of wanted to start, I guess, bottom up. So we and I guess that then would bring us to the colon. You've already told us that you can do transplants. So the colon, I guess, maybe we should take this from a level of
Love the sphincter, anal sphincter, or the rectum, or like how low are we going here?
as low as necessary to have you talk about what is I guess that's so it's the end of the digestive tract. What are the different functions there at the end? You know, we're working our way from bottom up. What is the colon? Is it just getting rid of junk?
Yeah, basically. Although it has very good absorption power as well. So um, the digestive system, which starts at your mouth and ends at the anus, is very complicated to allow us.
Sorry, does this podcast need a parental advisory?
Anus isn't a bird.
Only if the host is juvenile about it.
The host is super.
This is why we
juvenile.
weren't able to do that astronomy one.
Oh gosh.
Anyway, digestive tract.
Yes. Okay.
I mean, you don't want kids to call each other anus, I guess. Anyway.
I'm sorry.
All right.
Yes. There's a reason this podcast is called "Learn It from a Layman," and it's not because of Johnny or Matt. So go ahead, Johnny.
Starts at the mouth, ends at the anus. So at the end, I think it's easier to talk about that one from the top down. So first you put food in your mouth, and you start to salivate, and you have these specific glands that will help that so your saliva helps to start breaking down the sugars even in your mouth. Really, the only point of chewing is not choking. So it doesn't really aid in digestion or the breakdown of the food. So you're basically just chew everything until you're not going to choke. And so, and then after you swallow, it goes down the esophagus, which is an organ. And it works by peristalsis. So as the food...
before we jump into words I've never heard before,
okay.
What you said about chewing, that whole like best etiquette practice of chew each bite 30 times or something, that's all a lie?
100% a lie.
Wow.
That's what your parents told you so that you took some time when you were eating.
I don't actually know any. Yeah. Wow. Okay.
I've
Sorry.
I've heard that if you chew more, you're less likely to have gas problems.
That's also a lie.
All right, perfect. I love debunking the way I live. Okay, one other question.
I'm not going to say that I know everything, but that seems totally hokey to me. It doesn't.
Aren't you a doctor?
Which means I know how to use Google better than you for help. Basically all it means. No, I'm just kidding.
A little bit more than that.
Yeah.
One other question before you continue down the esophageal track or whatever. You talked about choking. So choking can happen two ways, right? Either you can inhale something that would otherwise fit down the esophagus, or you can try to swallow something that will not go down the esophagus, right?
Correct. So swallowing is pretty complicated and takes a lot of different it's a lot of different muscles that will work all together through almost a reflex. So once you start to swallow, you can't really stop it. I'm sure a lot of our listeners have accidentally swallowed an ice cube that got too close to the back of the throat. And it's not like you're like halfway through the swallow and be like, oh, I'll just reverse that. It doesn't work like that. So it's all automatic, and it's very complicated neurologically to swallow. It takes a lot of different muscles. You have to close off the airway. You have to, get that bolus down past the airway closure so that you can breathe again. And then the esophagus starts to basically carry that downwards. So
real quick, where is the airway closure so I can?
Yeah, so it's probably like right at the level of the jaw, in the very back. So if you open your mouth and look into the very back of your mouth, you will see.
Can we do for our YouTube viewers? You go ahead and describe. I will get close.
So, wow, Carl, that's terrifying. Maybe we need a rental advisory.
Yeah, now we need one for sure.
So in the very back of your throat, what you see like in the mirror, that pink, that is a space where your nose, your mouth, your esophagus, and your larynx, which is the first part of your airway, all meet together. So there's specific things that have to happen to protect you from, basically swallowing and it going down your airway. That's bad. That would cause choking for sure. So you have this special flap called the epiglottis, and when you swallow, it closes the airway, and then you swallow it, and then it opens it back up so you can breathe. So yeah, if you are trying to swallow something too big and it can't go down the esophagus, but you're mid swallow and you can't reverse that, I mean, the food kind of gets stuck in that area. Fortunately, at the very top of the esophagus, you have a little bit of muscle that you can use to kind of get things up, like a little, like if you almost swallow.
It's like your gag, right?
Exactly, yeah. So that's important to try to help clear your throat. And then if something goes down your airway, it will trigger you to cough. And that's how you clear your airway. So yeah, chewing is important. I don't want to choke. It's not fun.
Okay, so we got the esophagus. So go ahead.
Can we continue down the esophagus, or do you have more questions about the mouth?
That's it for now.
I mean, technically, each tooth is an organ too. So anyway, it's kind of interesting. So once you swallow, your esophagus is basically just a tube that transports food from your mouth into your stomach. Okay, and it works. If you imagine that you have, like, if you've ever seen someone like pipe a cake with frosting or anything like that, and how they'll start with the frosting up at the top of the tube, and then they'll squeeze it down with their hands all the way to the bottom to where it comes out. Or when somebody's milking a cow, they kind of they start at the top and squeeze down to make like the milk come out. And basically your esophagus through nerve pathways will tell. So when this food hits one part of the nerve, it'll trigger other parts of the muscle to relax and other ones to squeeze. So it squeezes at the top of this food bolus or food, let's call it like an apple chunk. It's squeezing at the top of this apple chunk to force it down, and it's also relaxing at the bottom to allow it to go down. So that's something called peristalsis, and it's how your whole gut really works, all the way from the mouth to the other part.
Thank you, Johnny. Okay, so we're out of the esophagus now. It goes straight into the stomach, right?
Yes.
And that's the part that most laymen are familiar with. It's okay, it's in my stomach now, my tummy, if you will.
Yeah.
No, I won't.
How long? Good. Okay. And is that down in your, below your rib cage, or where is your stomach generally?
Yes, it's below your rib cage. It starts on the left side, and then it'll go across your abdomen, which is the part below your rib cage, to the right side.
Okay.
So it kind of makes a little, starts over here and then kind of ends over here.
And it's filled with acid. Is that right?
Correct. Yeah. So it's not always filled with acid. There's usually some there, but as you eat and food particles start to trigger different receptors, it'll cause your digestive system to activate, and it'll cause your stomach to secrete acid. And you have like a nice layer of mucus within the stomach to protect it from the acid, because the acid's very, very strong acid. And basically what this acid is good for is taking these clumps of proteins, and the acid's so strong that it will make it so that these proteins can't be held together like they normally would be. They kind of just turn into a singular line of a whole bunch of amino acids which make up a protein all stuck together. So there's a whole bunch of amino acids, like this big long protein that is ready for these special proteins to come, and they just snip it like every 3 proteins. And then as it moves out of your stomach into the first part of the small intestine called the duodenum or duodenum, which is kind of a cool word. It's like duodenum. Like, it's nice.
Very nice.
You'll get more of that breakdown. So the stomach is important. All the while it's putting all this acid on it, your stomach is actually kind of grinding up the food and crushing it. Like one side of your stomach will really cramp down and crush the food against the other side, and then like takes turns going back and forth. And you have this little ending of your stomach called the pylorus, which has a muscle on it. And when it wants food particles to go through your stomach, through the end of your stomach into the duodenum, it'll open up. And then if it wants it to stay and get crushed somewhere, it'll close. So, and the stomach really, if you don't do a good job chewing, the stomach will do the rest for you.
And does all food, the time that the stomach keeps it inside, does that depend on different, biological factors then, or is it just 2 hours and you're out?
Yeah, I think it depends on how much you eat. So if you eat a huge meal, it'll stay in your stomach for longer because it's going to take longer to get those smaller particles out of your stomach. And then obviously, like, liquid things can pass through the stomach a lot faster. And then more complex things take longer to break down and are typically in the stomach for longer. Like high fat protein type meals can stay in your stomach for longer, which is why if you eat a meal that's like very high in carbohydrates, you typically aren't quite as full for as long than if you eat a meal that's high in protein and fats. It kind of keeps your satiety for longer, makes you feel full for a longer period of time.
Okay, interesting. And is all of that feedback, as far as like hunger is concerned, does that all come from the stomach, or does it the intestines as well, or?
It's complicated. So the stomach, when it gets distended, like, you can feel that make you feel full, but you also have hormonal secretions when you release insulin, when there's extra like sugar in the blood, that will end up getting released and making you feel full. I can't remember I know one of them's named ghrelin, is like one of the hunger hormones. So it's actually pretty complicated. It's not straightforward.
Okay, let's stay straightforward because this is a basics of organs.
Okay.
And we've already used a couple words that even Matt doesn't know. So, okay. Okay, we've gone from the stomach now. The stomach's done its crushing, and some of those amino acids are absorbed into the stomach lining, right? Or not?
Usually not. So usually the
Okay.
stomach kind of puts everything in a line. You may get a little bit of that cutting action, but not too much. It's not ready to be absorbed yet. So it gets taken out of the stomach and put into the duodenum. And at the duodenum, there's a
Duodenum.
duodenum. It's
All
nice.
right. Yeah, I like it.
So at the duodenum, this is and a very important part of digestion, because this is where the liver will take what it makes to help with digestion, the like bile acids and things like that, to help break down fats and things like that. It'll secrete that into the duodenum. And then your pancreas, which has a whole bunch of enzymes, like these clipping enzymes that make things smaller, it'll secrete all of those into the duodenum as well. And that's where the digestion really starts to happen, where you are breaking them down in small enough segments and things that you're starting to absorb those nutrients, even as early as the duodenum.
So if I understand you right, I've always wondered this. I've never understood. So the liver or livers, because we have two, right?
No, just one liver.
Well, if you cut one and then put it on the other side, does it regrow?
You are thinking kidneys, and they're completely different. Like, I don't know how even the layman.
Okay, well, whatever. 1, 2, you know.
I don't know. Actually.
Okay. So the liver and the pancreas, this is their function right here. So this is where they plug into the rest of the digestive tract, is right here in the duodenum.
Duodenum.
Yeah. This is their only function, right?
Yeah, so we can go a little bit more into the pancreas and the liver, because both are have other things that they do as well. So the function that we just talked about of the pancreas is called its exocrine function. So it'll take these things and it from inside the pancreas and get them out, so exocrine, into the digestive tract to help with digestion. But you also have an endocrine function of the pancreas, and endocrine secretes things directly into the bloodstream. So your pancreas is very important for the release of insulin and glucagon, which affect your blood glucose levels. So all of us nowadays know somebody with diabetes. Okay, there's two different types of diabetes, but let's just say type 1 diabetes, since it's more, it's easier to explain. Basically, what's happening is those cells that release the insulin in the pancreas, your body attacks them and they die. Okay, so your body cannot release insulin, and insulin is required. It's the key to open up the door of the cell to allow the sugar to go in. So your blood sugar levels go very, very high, and you get very, very sick because your body cannot use the sugar like it's supposed to use. And that's called, and that's diabetes, type 1 diabetes. So they have to take insulin, which will, correct that pathway.
Okay, so that's the pancreas, and yeah, like you said, diabetes is pretty. Most the laymen don't have the understanding that you just gave us, but we understand that it had something to do with the blood sugar levels, because that's, like you said, most people know someone with diabetes. The liver also, does it have another function?
Yeah, the liver does so many things. I'll probably forget some of the functions because it does so many things. One of the things that it does is so as your food travels through the intestine and as these particles get absorbed, some of these things are not supposed to be like digested, and they need to be cleaned, as or like the toxins need to be taken out, and your liver does a lot of that. So everything that gets absorbed in the intestine goes to the liver first before it gets pumped back to the heart, and the liver does some detox stuff to it. The liver also has an important function when your red blood cells die. You have something inside called hemoglobin, which helps carry the oxygen to the body. So when the red blood cells die, this hemoglobin's just floating around. It's not supposed to. So your liver helps to break that down, and it puts it into your poop. Can we say that, or should we say stool, Carl?
Poopy, preferably.
Okay. Um,
Doo-doo, if you will.
so it secretes it into the stool or into the poop, and gets rid of it that way. It is like a yellow-brown color, and it turns out this is what makes your poop brown, yellow color. So it's very important for that. And it also has some functions in controlling your blood sugar as well.
Interesting.
And
okay.
A lot of energy.
So the liver does a lot, like you're saying. Okay.
Yes.
Quick aside, though, for the layman, I may have in my life eaten crunch berries. Crunch berries have some magic power to change the color of my poop. Is this because they corrupt my liver? What is going on here?
Or is that just your genetic defects?
Yeah, it's probably a mixture of both. No, not doing anything to your poop. It's to your liver. Sorry, it's basically just not being absorbed. It's just the dye that's in the cereal, and so it just stays in your intestine and then comes out as a colorful bowel movement.
It's like a party.
Yeah.
Okay. All right. So the liver. You could probably talk about the liver for a while, like how many we have, for example.
Yeah.
What was that, John?
That for a while, it's one. That's all there is to say about it.
I think we need to look a little deeper. I mean,
this is learn it from a layman, not learn it from. Oh, never mind.
Okay.
Just getting bitter now.
Okay, but for real, the liver is one of those organs that can do some type of regeneration of itself, can't it?
Correct. Yeah. Yeah. And so life depends on the liver. That's
interesting. Thank you. We got deeper. See. Okay. All right. So we got the liver, we got the pancreas, we got the the duodenum.
Nice
close.
try. It was close enough.
I'm counting it. Which is part of the small intestine. The small intestine, does it have other sections? Because the small intestine is a misnomer, right? Like, it's huge.
Yeah, so the small intestine is smaller in diameter, but it's much, much longer than the large intestine. So its job is to basically absorb all the nutrients that it can. So the waste, the food products as they're traveling through the small intestine are still pretty watery. So they'll travel through the intestine. You have all these little tiny things called villi, which are like these little finger-like microscopic protrusions that help increase the surface area to absorb all the nutrients it can. Your body is very good at absorbing everything. And then once it gets into the end of the intestine, the small intestine, that's where, just as a side note, that's where the appendix is. And then it'll go into the large intestine. And the large intestine isn't that big. It starts at the right lower part of your belly, goes up to the right upper part, across to the left upper part, and then down to the left lower part, does like an S curve, and then exits the body.
It's a process we need to discuss. Okay.
This
really quick.
Triggered the last 45 minutes of our discussion.
It's important. It's an important part of the organs. Basics of organs. You must understand how excrement leaves our bodies. Okay, so small intestine, large intestine.
Cost of time to be discussing other organs, of course.
Of course. I would
experienced a bowel movement before. Like, Carl, there might be something more medically wrong with you than we thought.
I'm not even sure that's possible. I think I mean, speaking for the layman, I think every layman is interested in poop. So, we got the large intestine doing its thing. So at this point, the food has been digested. It's still going through some process different than the small intestine then?
Yeah, so basically by the time it hits the large intestine, all the nutrients have been taken out and absorbed by the body, almost all of them. So it's no longer like a nutrient-rich, I guess it's still
Mush.
Mush. That's a good word. So then as it goes to the small, from the small to the large intestine's major job is to absorb the water out of the material that's going to turn into your poop. So,
okay.
Dang it! How did Tim get on here?
We didn't plan well enough. Okay. Well,
I guess he came at the right time, just as we're talking about poop.
Yeah, we're getting right to the colon. So, right, because now the colon is what comes right after the large intestine.
No, the colon is the large intestine.
Oh, really? The same thing?
Yeah.
Wow.
I know.
Look at this information. Okay. So, and then from the colon, it's just a straight shot out the anus.
So you do like this upside down U across the belly, and everything's being absorbed. And then it does like this S-shaped thing. And then you have something called the rectum. Okay. So that's right before. And this is where all the fecal matter is stored until it stretches enough and sends your signal to your brain that says, we got to go right now. And interestingly, when you eat a big meal and it stretches out your stomach, there is an automatic reflex that triggers your rectum to squeeze down. So after you have a big meal and you feel like you need to go poop, that's why.
Interesting. So, it's like preemptive pooping.
Correct.
Okay, that's interesting. Okay.
I joined just in time to hear the conversation about the rectum, and I'm so glad my timing was good.
Interestingly, Tim is joining us from the toilet.
Hey, how'd you know? Is my location services turned on? Dang it.
Your video's on, Tim.
Oh, boy.
Okay. All right, now away from the potty humor, which we generally stay away from and learn it from a layman, but is unavoidable in basics of the organs, at least the way that I do it. One last question before we leave the colon and rectum and the variety. Sometimes you have big
Before
poops.
we move on.
It's
nice. A little bit of a stretch. Sorry. It's
a little bit.
Okay, moving on for reals now.
Okay, sometimes you have big poops. Sometimes they're like super big poops. And it seems like it shouldn't really be possible that is coming out of you. Does it back up out of the rectum into your colon if you wait too long? Or, I mean, how does that work?
Yeah, I mean, it's a one-way street. So if you close down the highway, it'll get backed up. So that's like, if you have like a bowel blockage, it'll usually present with like vomiting. So people will come in and just be vomiting uncontrollably because nothing can pass through and it backs up and then it comes out the mouth. Stooling out the mouth is something that is very rare. So don't worry too much.
Oh my gosh, I think I just got sick. Oh, okay. Wow.
But this is something though for our listeners to think about. Every day, somebody takes the biggest poop in the world for that day and has no idea.
Oh my gosh.
That's deep.
This
Oh,
is what
this
you
is
really
wonderful.
get from medical school.
Oh my gosh. This might be my favorite learn it from a layman fact ever. Okay. I don't really want to move on now, but I think we're going to.
Okay, so
Okay, so we could talk about the brain, but we actually already have a podcast about the brain from Johnny. So nice try. Go listen to that one. But let's talk quickly because we just spent like 30 minutes talking about the poop. Let's talk about the heart and the all of the related parts.
okay, so let's talk about the respiratory system and circulatory at the same time. So um, basically what the function is your body needs oxygen in order to burn sugars. Okay, so so in order to get that from the air to each of your cells, the lungs and the heart work together to do that. So you breathe in, the air goes down the trachea, and then it divides into the two. It divides into two smaller tubes, and then those tubes divide into smaller tubes until you get down to like very minuscule single-celled walled structures in your lungs. Okay, so this membrane is very thin, and it's so thin that it allows gases to, not that type of gas, Tim. It allows gases to diffuse across the cells pretty freely. Okay, so
Especially in Tim's case.
in Tim's case, we usually think about the lungs exchanging gases, but in Tim's case, we think about other systems exchanging gases.
Uninhibited. It's not a bad thing.
Well, that reminds me, what's the smartest muscle in the body?
Oh boy.
The brain?
It's not a muscle, but nice try, Carl. It's the anal sphincter muscle, because it's got to know the difference between a solid, a liquid, and a gas. So anyway, again,
Dr. Jokes.
favorite. Learn it from a layman fact.
You're breathing in air, okay?
Yes. Okay.
So the oxygen particles get all the way down to these structures at the very end called alveoli, and it diffuses into the blood. It diffuses into the blood because the oxygen content in the blood at the lungs is very low. So it wants to go and attach to the red blood cells, okay? So the way it attaches to the red blood cells, the carriers of the oxygen, is called hemoglobin. So that's inside the red blood cells. Remember, we talked about it earlier. The liver breaks that down. That's why your poop's brown. Anyway, so the red blood cells, they attach the oxygen, and they're basically the cars that are going to go deliver this to the rest of the body. Now, the problem is that now that they're full of oxygen, they have no wheels. So they need to be pushed by a pump all around the entire body. So what happens is this blood cell that's in your lungs that's full of oxygen gets pumped back. It goes to your heart, and then from your heart it goes to your body. And as it goes to your body, it gets into smaller and smaller and smaller blood vessels until it gets to one of those single-walled blood vessels, just like the ones that are in the lungs. And the red blood cell has a lot of oxygen on it, and that tissue or that area that it's at has very low oxygen. And so by diffusion, again, the oxygen decides to jump ship and go to this area that needs the oxygen. Now the blood cell doesn't have any oxygen on it, and it has to get back to the heart. So as the heart continues to pump, it comes back to the heart, and then the heart will pump it to the lungs. It'll get more oxygen. It goes back to the heart, and then the heart pumps it to the body to be delivered, to deliver the oxygen again. Now, it turns out oxygen is pretty hard to dissolve into water, which Matt could probably explain better than me. But carbon dioxide is a little bit easier to do. So as your blood comes back to, well, you probably don't know why there's carbon dioxide. Maybe we should take a step back. Okay, so this oxygen molecule is taken to the body to be used in metabolism. I know you guys have probably heard the word metabolism before, but what's happening is your body's using a source of energy, whether that's, let's say sugar, for example, and it's using oxygen in this reaction, and it creates carbon dioxide, water, and energy in the process in the form of something called ATP. Okay, so think about it: the oxygen and the sugar, it reacts together, it forms carbon dioxide, water, and energy. So now you have this buildup of carbon dioxide, which if you get too much carbon dioxide in something, it'll make it acidic. Your body does not like that. So you got to get the carbon dioxide out. So it dissolves into the blood because the blood at that area is low in carbon dioxide, that the oxygen has just been dropped off. So it gets absorbed into the blood. It goes back up to the heart, gets pumped into the lungs. And since the lungs, the outside of the lungs, are very low in carbon dioxide, this blood is very high in carbon dioxide. Once again, you get this unloading of the carbon dioxide that you breathe out. So you can actually, interestingly, you can take a straw and just put it in water, and you can blow just into the water through a straw, and it will actually make it more acidic. You might not be able to make it bubble like soda, but you can make it more acidic by doing that, just by dissolving that carbon dioxide into the water. It's much, much harder to get oxygen to dissolve into the water, which is not why it needs the extra carrier of the red blood cell. So let's talk a little bit about the heart, because that's interesting for people. The lungs, you know, they exchange gases. The heart, it's the pump that, circulates the blood through our body. And like I was explaining before, it has an intrinsic beat. So it has it's basically like an electrical signal through tiny little charged particles that are passing through a membrane that cause it to have this beat. When you run or exercise, what you do is you increase the amount of carbon dioxide in your body, and it triggers your brain to say, hey, we need more oxygen to the body and we need to get rid of more carbon dioxide. This makes your heart beat faster to be able to circulate the blood faster, to be able to get more carbon dioxide out and get more oxygen in. So that's a pretty neat function of the brain and the lungs and the heart all working together to make sure that you don't die when you exercise.
That's good. So I can tell my mother-in-law that I can run as fast as I want because my brain will make sure my heart pumps the blood.
Or you'll pass out before you die.
Right. Either one's fine. Okay. Quick question about the lungs.
Mm-hmm.
Is the diaphragm, is that an organ or just a collection of muscles?
Yeah, the diaphragm is a muscle, and it is an organ. It's very important for the lung function, and it's kind of hard to explain exactly how it works. It's more like a suction cup, okay? That's pulling down on your lungs, and then as it pulls down on your lungs, it creates a negative pressure inside your lungs, which forces the air from the outside to go into the lungs. Okay, so this is different than like if somebody is really sick and needs a breathing tube, we're actually just pushing air into their lungs through the tube. But really what's happening with your diaphragm is you're pulling air into your chest and filling up your lungs with volume. So So it can be pretty damaging to your airways to have like this breathing tube pushing air into your lungs, because it's not really how your lungs are meant to fill up with air. So it works all through pressures, and it can be very, very complicated.
Okay. A couple things that we haven't mentioned yet before we get to the how things explode inside your body end of the podcast. For those listeners that might be waiting for discussion of reproductive organs, we'll kick that to a different podcast unless Johnny really wants to talk about it.
No, we can talk about like urine, but we won't talk about the reproductive system. We can save that for that one. Will get racy for sure.
Good. Okay, let's talk a look because we haven't talked kidneys. We can at least talk kidneys, bladder, right?
Yes. Yeah. Absolutely. So, any questions about the heart, lungs before we move on?
Those are pretty simple, I think.
Yeah.
I'm kidding. I've heard that the heart's one of the simplest muscles. Okay, no. I'm sure there would be a bunch of questions that I could ask, and some are interesting to me. It feels like that one, because I'd like to have a podcast where we talk about heart surgery sometime in the future.
Okay, yeah, that would be interesting. One thing that is interesting about hearts is the sound, because if you put your ear up to someone's chest, you can hear the heart sounds. So basically, to get the blood to flow the right way through the heart, all the heart's doing is squeezing down. To get the blood to move in the right direction, you have one-way valves that direct that. And as the valves close, they click. And that's what you hear as your heartbeat. So that's
interesting.
An interesting little tidbit. But yeah, let's move on to the kidneys. The kidneys are... they also do a variety of things. So their main function is to be. Oh, I'm sorry.
Oh, I was just wanting to clarify. There are 2 kidneys.
There are 2 kidneys.
That one I got. Not 3, not 1.
Well, yeah, there's one for each liver.
Yeah. So there are people that are born with 1 kidney. There are people that are born with multiple kidneys, like more than 2. And there are people that 1 kidney that is horseshoe shaped, that covers like the whole, that like horseshoes from one side to the other where the kidneys are. And it's called a horseshoe kidney.
Wow.
Anyway. So
does it work?
Yeah, it works.
Hmm.
So if the kidney doesn't, you die. So everyone that's alive has working kidneys or is on dialysis, which is pretend kidneys. So the kidney's main function is to filter the blood. Okay. So as blood passes into the kidney, the kidney is a little bit leaky, has like this leaky membrane that will allow certain things to go through. And it's basically only based on size. So if it's small enough, it gets filtered into the kidney. Okay. And so you have this separate liquid from your blood that is building up in the kidney. It passes through these different tiny little tubes within the kidney. And in these tubes, it will reabsorb certain things like sugars. You want to keep those in your body. And then it will do other things to balance your electrolytes, like your sodium, your potassium, your calcium, the chloride, the bicarb, which is helps your acid and base, your phosphorus. All these things are controlled by the kidney. Okay. So the electrolytes have to be in perfect balance. Otherwise, you'll have major problems with your body. So as these things get reabsorbed, you finally make your end product, which gets to this end thing, and you've absorbed as much water as you need to off of it. If you're dehydrated, it'll absorb as much as it can. And if you're very hydrated, it'll absorb very little. And what comes out of this tube is urine. Okay. So if you're drinking a lot of water, your body is not going to need to reabsorb as much water as is getting filtered. So you'll pee more. And if you're really dehydrated, you have these special tubules that will help you extract as much water as you can, and then your pee gets more concentrated. So when you're dehydrated, your pee is typically a darker yellow color. And if you're hydrated, it looks more like water, more clear. So it drips off of the kidneys, of these little structures in the kidneys, and will pass down something called the ureter. Okay. So the ureter, I'm sure that you've heard of kidney stones and that type of a thing. The pain, that's where this comes from. Okay. The ureter is very sensitive to stretch. So as this sharp object called a kidney stone passes down the ureter, it scratches it and stretches it, and it hurts really bad. So urine, on the other hand, doesn't stretch it. It just moves right along through, and the two ureters attach to one bladder. Okay. And the bladder has these specialized cells in it that allow it to be very, very stretchy, and it's also compressible. So as the fluid builds up in the bladder, like you can actually hold a lot of urine in your bladder, and then at some point it will trigger you have these muscles inside the bladder that will squeeze, and it puts pressure on you, and it tells your brain like, hey, it's time to empty this thing. Okay. And we're adults are pretty good about like saying like, no, I'm not going to go right now. No, I'm not going to go right now. No, I'm not going to go right now. But eventually you get to the point where like, I got to go right now. And that's just dependent upon how full the bladder is and how well it's squeezing. So once you go to the toilet, you relax all the little tiny muscles that are little circular muscles. You relax all those, and you have that muscle inside the bladder that squeezes it and drains the entire bladder. And that's called urination or peeing. So your kidneys are very, very important, and it's important to try to stay hydrated, to take good care of your kidneys, because if you're not getting enough fluid in them, it can make you you sick if your kidneys start to fail or give out. Some other functions of the kidney, it actually is the trigger to release a hormone that makes you make more red blood cells. It also is it communicates with like your bones and with your intestine to absorb calcium, which is important. So like those are just some of the other. Oh, and it's very important in the control of your blood pressure, to make sure that everything in your body is getting blood to it so that it can have that oxygen like we talked about earlier.
So kidneys help determine your blood pressure?
Absolutely, yeah.
Really?
Yeah, so they have a special sensor in them that will tell it how dehydrated or hydrated you are. So if you're, let's say, for example, you're dehydrated, okay? So your total body water is low, which means the water inside your blood vessels is low. So you don't have as much blood to circulate, okay? So as this water filters into the kidney, a lot of it's reabsorbed, and the and since the what's re so what hits this sensor is more concentrated, it's telling your body that it's dehydrated, which cascades a signal of different hormones and different things like that that will actually raise your blood pressure. So let's say you have, so it's basically all based on how well your kidney's being perfused. So if your kidney's being very well perfused or too well perfused, it'll help get rid of some of that water to try to control your blood pressure. If it's not being perfused, then it'll say, hey, I need a little more pressure to get blood into the kidney. And so it'll squeeze down on some of the blood vessels to get more blood into the kidneys and to the different areas of the body. because remember, everything works on a pressure gradient when it comes to the heart. So if you don't have a high pressure to a low pressure, then you're dead. If your blood pressure is one number, instead of the two numbers, the high pressure and the low pressure, if it's one number, that means that you are dead.
You're dead.
Yeah.
Okay.
Nice.
So, good to know. So the both numbers important, it turns out.
Yeah.
Okay. All right. So we're at our normal length right now, but we can't finish our podcast without like paying off the
Talking
T's.
about
Like,
spleen.
I do want to find out the spleen, but that'll have to be a different podcast because the most important thing, unless your spleen can rupture. So what I want to know, Johnny, is so there's appendicitis. Maybe we should briefly, like appendicitis. That's a thing that it's not all that not all that uncommon, right? But it's super dangerous, and your appendix bursts, right?
Yeah. So it can. So basically what happens is, for some reason, the appendix starts to get an infection in it. Okay. This can be because you have a little poop rock, basically, that plugs up the area that is going. So the appendix is hollow. So you get a poop rock that blocks it, and past that poop rock, those bacteria are going to go wild because they're not in check anymore by the rest of the digestive system, and it's going to make an infection. So just like any infection, you get a bunch of blood cells that come to it, other types of things, and it gets red and swollen. Same things happens to your appendix. Okay. So it starts to, usually the pressure from the appendix getting pressure inside of it and wanting to like stretch, you'll feel that around your belly button, and it's called referred pain. So things in the lower parts of the intestines will hurt when you have this stretching, hurt around your belly button. And then as it gets more and more inflamed, it starts to hurt, or I guess it lays up against other structures, and those other structures start to get inflamed too, which is how you get the really bad pain that's right down at the right lower part of your stomach. And then eventually the appendix can burst. So that's called a ruptured appendicitis. And there's a couple different ways to treat it, but it's a medical emergency. So appendicitis is something we always look for because it's something that we do something about right away. It's not something that you just kind of wait on. And it usually happens pretty quick. Like within a day, somebody goes to totally fine to, I feel like I'm going to die from this pain. And then they can get other things too, like fevers, because they have like this big inflammatory response to this infection. And a lot of times we catch it before it pops or bursts. So a surgeon will go in, they'll take out the appendix. If it has burst, they'll try to clean it up as much as they can. And then typically we try to mop up the rest of the bacteria with some antibiotics to make sure that they don't get another infection inside their belly. But if it bursts, they have all that bacteria that's inside I'm sure you can imagine your gut, like especially when it gets close to your colon, is not like a clean place.
Not a pretty place. Yeah.
Yeah, there's lots of different bacteria in there, and the bacteria actually aid in digestion and signaling and that type of a thing, which we can talk about on another podcast. But as this area bursts, it opens up basically from the inside of your intestine and a highway to the outside of your intestine. And you can get really bad infections within your abdominal cavity, which is the lining of basically your stomach, your tummy wall, and the intestine. There's like this space that's not really like a big space filled with anything. But if you start spilling gut contents out, the bacteria can go wild because there's no immune check in that area. and it can make really bad infections that you're hospitalized for.
Right. Okay. Interesting. That's so that's your appendix exploding, which
Yes.
not quite as combustive as I had hoped, but I guess it's interesting.
Yeah, you don't like the fuse or anything. I mean, it's not.
Okay, and then last one before we finish the podcast. Then you mentioned the spleen. I've heard of ruptured spleens before. I think that only happens when you get hit really hard, right?
Yeah, typically that's what happens. Spleen lacerations is basically when you get a cut on the spleen. The spleen, you can hold up to, I don't remember what percentage it is of your blood in your spleen, but it's crazy. It's like 20% or something. So like you can hold a ton of blood in the spleen. And what the spleen does is it has a specific immunological response to take out certain bacteria from the bloodstream and kill them before they go wild and create all sorts of problems. So it is a very important organ. If it gets ruptured and you're bleeding really quickly out of it, it's not as important at that point. So you can get it taken out. So for example, there was a pregnant person that came to the hospital that had gotten in a car accident. Okay. And she had ruptured her spleen. So the spleen, this laceration can bleed very quickly because it has a lot of blood in it. And I don't know if you've ever like cut your head or anything like that, but it can bleed a lot. Your spleen bleeds a lot more. So they delivered the baby by cesarean section because the blood volumes were going down so quickly. And we were able to save that baby, which is great. It was a little bit premature, but the baby did totally fine. But yeah, so the spleen rupturing can be very, very scary. So this lady, she needed several blood transfusions. They did an emergency surgery on her to remove the spleen because it was bleeding so much. And yeah, you basically are bleeding out, but it's bleeding out into your body.
That sounds horrendous.
Yeah.
Where is your spleen?
So your liver is like up on the right side at the top, and your spleen is underneath your rib cage. So it's kind of like up underneath your rib cage on the right side. Your spleen is on the left side up underneath your rib cage.
So below your heart.
Well, the heart's more in the middle. I know you thought it was on the left, but it's actually
okay.
It's a little bit on the left, but not as much.
Okay. All right. Well, it's good enough for me. I've had many parts of
kind of below the
what,
heart.
Johnny?
It's kind
below
of
below the heart.
Okay. At one side of the appendix. Not the appendix, I'm sorry, the pancreas.
The pancreas.
The pancreas. Okay. I'm confusing everybody now.
No, that's my job, Johnny. What they can take away from this podcast, if nothing else, one liver. One. For now, until we find more. Okay, awesome. Well, there are. What is that, Johnny?
Until we find those secondary livers.
Next podcast. Okay, awesome. Thank you. This has been great. One quick check-in on our listeners. At one point, we had just as many UK listeners as we had listeners in India. Our India listeners are now like twice as many as the UK. So I think what it means is we all need to go to India.
Okay. I'm down.
Perfect.
So if anyone has any feedback, or if they want to learn more about a specific part of the body, please comment and let us know. Email us, whatever, so that we can put together a podcast on the things that you might be interested in listening to.
Yeah, because it turns out Johnny has a lot of information. You can't distill 4 years of medical school and 4 years, was it 4 years of residency? How long have you been?
3 years.
Is it, I don't know, 3 years. 3 years of residency into an hour podcast. So we really tried.
Yeah, we really did. And all we learned is on liver. So I hope somebody something else.
Not true. We got the best fact in the history of learning from a layman. Someone today had the biggest poop in the world.
Unknowingly.
Okay. All right. On that note, we'll be back again in the near future, and tune back in then. Thanks.